Hey, Bob Barnes here from Nordic Energy. I'm going to be recording a demo video today on our Odin product, which is about identifying projects for energy infrastructure. I'm going to be using the heat network module for our demo today. Let's crack in. This is our home screen where you can have a look at projects that you've seen in the past. You can zoom in, edit, delete, and as projects progress, you'll have more options here about taking through to the next tool, which we call Thor, which is our delivery project developer tool. So to start with, we'll start by starting a new heat network. It's going to take us to our mapping interface. So it's based on Google. We're all familiar with this, and the idea is because of our familiarity with this kind of interface, it makes it really easy to look around our cities or our whichever kind of geographic area you're looking at. I've got Peterborough on the screen here. That's been our pilot project for our tools that we've been developing. So let me take you, first of all, I'm just going to minimize that. Let me take you through some of the stuff here. We can put whatever title you want in there. So I might want to call it Peterborough. I'm just going to call it Peterborough Bob just for now, so I can identify that later as I come back to it. If we open up the menu bar, we can go back to home, and then I can click straight back into my project there. Other options I've got from that home tab. Oh, projects button also takes me straight back to that home tab, and we've got tips and tutorial. So we've got the heat source labeled here, and we're busy filling this out as we speak. We're going to have tips on the rest of the workflow to come. Obvious buttons: zooming in and zooming out. Contracting that. After you've been in and had a look, you can reset everything to north. All the usual stuff. Okay, let's have a look at some of the layers we've got on there. Buildings, if I zoom in a bit more, you can see it's highlighting the buildings there with a bit of a purple overglow on there. And when we've selected particular buildings for our heat network, let me just click on this building here. There we go. CIBSI category, we don't know which category this particular building is. Heat demand, we've got an estimate of the heat demand, 219 megawatt hours per year, and a peak heat demand of 200 kilowatts. Let's just zoom into that one a bit and have a look. Yeah, not sure. It looks a bit like a school to me, or maybe a leisure complex. So let's add that connection. You can see as I've added that connection, that's gone into a dark purple color. So there's a difference there between the light purple and the dark purple. And I can toggle those on and off. Now, as I zoom out more, that difference between the light and the dark becomes more obvious. The next bit we might want to look at is the heat network zoning. You can see this flashing on over there as I toggle heat network zone on and off. These areas are shading. So what's that there? So this is a zone area known as Morley. So this will have been identified as by national government as part of their zoning program to have a look at areas where heat network clusters might work quite well. So that's something that's been done on a kind of national, it's a statistical geographic model that looks at the amount of heat demand that there is and clustered quite closely together. So if I were to look at Peterborough, I've got a few of these around the city. The biggest one is here, Fengate and Bourges. If I can zoom into the extent of that. And that's basically the heart of this centre there. You've got the cathedral in here. I can zoom in right in here. That's going to be this area here where you've got the beautiful Cathedral of Peterborough. And so it's taken us through the layers of the map. Another thing we might want to look at is land ownership. So let's have a click on that section there. We can see we're highlighted in red, CC projects, freehold tenure, unlimited company, and we've got the address of it, the registered address of the owner. And we've got this title number, so we can start looking at the land registry to get more information out of there. Domestic properties, you're going to see not a lot of information on here. Domestic properties tend to be private information. It's the commercial properties where you will see more useful information. And that means that when you're planning a heat network or any of the other infrastructure projects that we're talking about, you need to be contacting the buildings or the building owners. We've got an avenue in towards them from the start. So let's take that layer off. This is our heat source icon right here. So what we're going to be doing with this heat source icon is identifying sources of heat, and then we'll plonk that icon on top of the sources of heat. Now, in a city, you're likely to have several different sources of heat. Heat networks work really well when you have a waste source of heat. If you're generating the heat from scratch using heat pumps, air source heat pumps, it works, but it's not the cheapest way of doing it. You ideally for heat networks, you want a waste source of heat. So industrial waste heat is great. If you've got a power station that's churning out heat, so think of the big chimneys you're used to seeing around your cities and stuff. If someone's got a big chimney, chances are they've got some waste heat somewhere. So it's about tapping into those resources. If your city has ceramics works, glass works, could be breweries, be energy from waste plant. You're not going to have coal-fired power stations anymore, but you might have biomass power stations. Something that's churning out large amounts of heat, sewage works, sewage plants, or even the sewers themselves. They can all churn heat. In London, you're looking at the tube stations. Data centres are increasingly popping up as sources of heat for heat networks. So here, I'm going to zoom into this area here, and I happen to know that this one right here is an energy from waste plant. So what I'm going to do, we'll designate that as a heat source. We'll put that there. My click's gone a little bit off it there. It's there, but it's that's where our heat source is going to be. We're going to have a look at the settings we could put on our heat source. So we can choose it. Gas, biomass, hydrogen, electric, air source, waste source, geothermal, recovered heat are the main options here. So gas boiler, we're obviously moving away from that. The whole point about decarbonisation of these projects is we're moving away from gas boilers, so we don't want much of that. Biomass boilers are a thing. They're not that common, and where they have been installed, they tend not to be run that frequently because they have they're not always easy to maintain, and delivery of the fuel is a challenge through cities as well. Hydrogen boilers, you'll have certain elements of the industry telling you this is a great thing. Hydrogen is going to be expensive as a fuel. It would be more expensive than electricity because it's produced by electricity. So it's never going to work out cheaper than electricity, and it's produced not in an efficient process. So it will always be more expensive than, say, an electric boiler. So it's just not going to be a big thing. Air source heat pumps are going to be very common, and we've also got waste source heat pump here, and we've mentioned geothermal, recovered heat. All of these are very, very similar concepts. Nearly all of them will have a heat pump. Heat pump just means you're pumping the temperature of heat up from one temperature to the temperature that you want it at. And then where you're getting that heat from is your source. It could be from the air. Of course, if it's summertime, your air starts at 20 degrees. If it's winter, your air starts at 0 degrees, 5 degrees, something like that. So you've got harder work to do in the winter. Waste source heat pump is probably a consistent temperature all year round, depending on where it's coming from. Similarly with geothermal, if you get it out of the ground, it's going to be consistent temperature all around, which might be, say, 10 degrees C. And if you're recovering heat from industry, if you're lucky, you'll get it up at 30, 40 degrees C, in which case getting it up to your 70, 80 degrees, whichever temperature you need it at, will be a lot easier, cheaper to do. So those are the options we've got. So we're going to select covered heat there to represent our energy from waste plants. That's recovered heat. We're recovering the heat from that technology. And we've spoken to the business owners there. We know they've got up to about 10 megawatts of spare heat capacity available. And then we'll be thinking, right, let's let's add in some extra heat pumps on top of that. The next phases are all, you've got iterative design processes to go through. So how big is your heat demand? How big is your heat supply? How do you make those match to a certain extent? So we can select. You're nearly always going to have gas boilers as your tertiary, your backup emergency plant. So everything else fails, you've always got your gas boilers to run from. You're not planning to use them, or almost never. Maybe on a particularly cold day in winter, you chug those on because nothing else can cope. So they supplement the rest of it on really cold days. But other than that, you're not planning for them to run. They're there as emergency. And so if you know that you can't do most of your load with just your 10 megawatt, would add in some heat pumps to go with that. So your primary will be this one. That will be cheaper than running heat pumps, and that will be a good base load throughout most of the year. Your source heat pumps will provide quite a lot throughout the slightly deeper winter when you need a bit more heat supply. And then your gas boilers are there for emergency. Right. How much? And that's the heat plant that we've been dealing with. So let's go back to here. We have plonked down our heat plant just there. That's our heat source. I've just kind of moved it there. Let's put it back there. I've hidden my icon behind the building. There we go. There's my icon. Can select. Let's think about heat demands now. So we've got that there. We know what heat source we've got, heat supply we've got. And this is all iterative, so we'll come back